Okay, we got foam. We'll give it about 30 seconds. I'll take a sample.
Once they have collected the samples, the person taking the foam solution sample should radio back to the person stationed at the bladder tank to close the foam concentrate isolation valve.
Shut her down, Jerry.
Shut down.
Okay, it looks like we got her flushed down good. We can shut it down. All right, now we're ready to take these samples back and test them.
At this point, pressure is relieved from the pressure sensing line to the hydraulic actuated concentrate valve actuator, and the valve is manually reset to its normally closed position. Then the foam concentrate isolation valve is returned to its normally open position. The foam solution samples are then ready to be tested via either the refractive index or conductivity test method. Commission testing the Ansul bladder tank.
We've completed doing the discharge test through the hose monsters and the play pipes at the outside of the facility, and we're now ready to test for the concentration percentages of those discharge samples that we took. What we've taken is we've taken samples of the concentrate from the foam bladder tank. We've taken a sample of the fire water that's used to support the design of the system. From the discharge test we did yesterday, we have the interior tank farm foam discharge samples that we collected, sample number 1 and sample number 2. We're going to go over with you the types of instruments that we can use in doing the test. Basically, it's either using refractive index method or conductivity. We have two types of instruments here, which are refractive index meters. The first one is an optical device, which you read a scale, the light is bent as it passes through the prism, and you take a reading on the scale, looking through it similar to looking through a telescope. The second instrument is also a refractometer, but it gives you a digital readout. So it's very easy to use, it's user-friendly. The next type of instrument that we're going to demonstrate the use of is a conductivity meter. A conductivity meter has a probe, and we're measuring electrical conductance between the two probes inside of the, so similar to a pH meter of sorts. First, we need to make up what we call calibration standards. Calibration standards are known mixtures exactly prepared using the concentrate and the water from the system. We're going to make up 200 milliliter samples, calibration samples, one at 2%, one at 3%, and one at 4%. To make up the 2% calibration standard, being we're making up a 200 milliliter sample, we need to measure 196 milliliters of water and 4 milliliters of the 3% AFFF concentrate. Jerry's going to be measuring the water in a graduated cylinder. I will measure the concentrate using a syringe. First, Jerry's going to measure out exactly 100 milliliters of water. We can use an eyedropper to raise or lower the level of water in a graduated cylinder. And when he's using a graduated cylinder, he's reading the meniscus. Again, this is the 2% premix calibration standard. We're making up a 200 milliliter sample. So 98% of 200 milliliters is 196 milliliters of water. And if he goes over the level, he can simply use an eyedropper to take a small amount of water. And we want to be as exact as we can when we're doing this. So we first have 196 milliliters of water. And next I'm going to measure 4 milliliters of foam concentrate. Notice I have my samples. All our samples here have been covered. And I have both 10 cc syringes and 5 cc syringes. So I need 4 cc's. I'm going to use my 5 cc syringe. I have it slightly overfilled. I'll tap the syringe. I'll get any bubbles out of it, so I just have clear liquid solution in the syringe. I'll adjust it where I have exactly 4 milliliters or 4 cc's of the concentrate in the syringe. I'll add the foam concentrate to the water. Jerry will stir it. And we'll have our first calibration standard made. The reason I'm putting a cap on it is that I don't want evaporation to occur. Next we'll do the 3% premix. In this case we'll have to measure out 194 milliliters of water. And next I'll want to measure 6 milliliters of foam concentrate. Lastly, we were measuring the 4% calibration premix standard. And while Jerry's doing that, I'll measure the 8 cc's of concentrate. And we'll mix. Now with some types of foam concentrate, such as 3% AFFF or JetX high expansion foam concentrate, you can mix them very easily just by stirring them. With some types of foam concentrates, particularly the alcohol-resistant foam concentrates, you need to physically mix them. And then inspect them to make sure that you have all the concentrate mixed in to the solution. And again, with this type of foam concentrate, it goes into solution very quickly. We don't have to do that. But again, with an alcohol-resistant foam, we would.
Commission testing the Ansul bladder tank. Foam system testing, refractive index test method.
We have the discharge samples that we collected when we did our test yesterday. And we're going to select using a refractometer in this case to determine if our samples test out within the required 3 to 3.9% range as required by UL. First thing we're going to do is we're going to test water. And then we're going to fill this about halfway up this conical shaped sample container. We close the lens. We hit a button that says go. And the refractometer gives us a reading of the water being 1.3331. I record that information on the form that I'm using. Next, we'll do the calibration standard of 2% premix. This is giving a reading of 1.3334. I'll record that information. Next, we'll do the 3% premix calibration standard. And when we're doing this, we really want just the clear liquid solution. We don't really want expanded foam bubbles. .3335. .3338. And if there are any points that you had which were suspicious to you, you could certainly go back and retest them. And I'm going to do that. I'm going to test the 3% premix standard one more time. And I do. I'm getting 1.3335. The last thing I'll do on the refractometer is take a reading of what the refractive index is for the pure undiluted foam concentrate. This is giving us a reading of 1.3511. And that would be a typical refractive index reading of the concentrate as indicated on the Ansul technical data sheet for the type of foam concentrate that's charged in the system. Next, we're ready to test the discharge samples, which we have in front of me. So sample number 1 from the interior tank farm, and sample number 2 from the interior tank farm. And as you recall, I took 2 samples. I took one at approximately 30 seconds, that was sample number 1, and then one sample at approximately 40 seconds, which was sample number 2. And that was roughly the time from when we first started to see foam coming out of the hose monster. So we have a clean eyedropper. 1.3337. Thank you. Next, we'll do sample number 2. And on the second sample, we're getting a reading of 1.3338.
Commission testing the Ansul bladder tank. Proportioning system, known concentration graph.
So we need to determine what those numbers mean, what concentration those samples are. And so on the form, we have a grid that we can plot out percent concentration. Y-axis, we're going to put concentration percentage. 0%, 1%, 2%, 3%, 4%, 5%. On the x-axis, we're going to put refractive index readings. Again, creating a linear scale. I'm going to start out with 1.3330. I'm going to make this 1.3332, 1.3334, 1.3336, 1.3338, 1.3340, and I'm going to plot out the 3 calibration standards plus what water read. Water gave me a reading, or 0% concentration, gave me a reading of 1.3331. That's that point. 2% gave me a reading, 2% gave me a reading of 1.3334. That's that point. 3% gave me a reading of 1.3335. That's that point. And 4% gave me a reading of 1.3338. That's that point. We draw the best straight line through these points. It's probably a curve that looks like this. So we have 2 points below the line. We have 1 point that's almost exactly on the line and 1 point that's slightly above the line. Our sample that read 1.3337, which is this point right here, was reading about 3.8%. Our sample that was reading 1.3340, I'm going to call that 4% because it actually fell right on the reading, but if I read it off the chart, it'd be reading about 4.3, but I'm a little suspicious about that point. I'll write down 4.3%. So our concentration percentage on the first system that we tested with Flomax was proportioning foam concentrate on average of about 4%.
Commission testing the Ansul bladder tank. Foam system testing, conductivity test method.
Next, we're going to be doing the concentration test on the discharge samples that we pull from the tank and rail car deluge system. To demonstrate using conductivity, here's our conductivity meter. We'll connect our sample probe to the meter.